Okay, so now for a slightly more complicated example. What does the graph of f of xy equals x squared plus y squared look like? So here again, let's say x squared plus y squared equals z. If I'm asking you to think about something geometrically, then you can safely assume that I'm assuming that f of xy is some height. And so x squared plus y squared equals some z. If z was fixed, this is a circle, right? It's a circle of radius square root z, centered where? Well, x squared plus y squared, that's going to be, well, actually, x squared plus y squared is a cylinder, right? I mean, x squared plus y squared, all of these circles are going to be centered somewhere on the z-axis, and the height is going to be given by z. So this is centered at 0, 0, z. Now, what these circles look like remains to be seen. Let's maybe try to graph some of these. Well, I know at least right here at z equals 0, I have just a dot, right? Radius 0 circle. At z equals 1, let's see, I have the circle x squared plus y squared equals 1. And so here is x squared plus y squared equals 1, and z is equal to 1. So that's that curve. Up here at z equals 2, I have a circle x squared plus y squared plus equals 2, and z equals 1, or rather 2. And so this is now a circle of radius square root 2. And finally, let's just say up here maybe at z equals 4. This is not to scale, of course. At z equals 4, I have x squared plus y squared equals 4. So that's a circle of radius 2. And if we start to actually draw what this thing might look like, we'll get something like this. Maybe a better way to do this, maybe a better way to think about this is what happens when we fix some of these things. So here we're in this picture, on the left here, we're fixing z, right? We're saying, okay, if z is equal to 0, if z equals 1, if z equals 2, if z equals 3, what happens? What happens if we fix x equals 0 or y equals 0? Well, if x equals 0, then I have just the equation z equals y squared and x equals 0. And so that will look something like a parabola opening up. So this is z equals y squared, x equals 0. Remember, if I leave out that x equals 0 part, then I have a cylinder, or rather some extruded, we called it a trough, I think, some extruded parabola, right? It would keep going in both directions. What about when y is equal to 0? So when y is equal to 0, we have the equation z equals x squared, y equals 0. And so that's going to be a parabola opening up like this, maybe. And remember, I have circles everywhere. And so so these are going to be circles where everything's defined by parabolas. All of the edges are defined by parabolas. Or if you think about it from Calc 2, this is one parabola that's spun around the z-axis. This is called a paraboloid. And this is our first sort of very complicated looking, but very simple to state and eventually very easy for you to draw and recognize, our first three-dimensional surface, a paraboloid.